Hello guys. Today we are going to solve the LeetCode Daily challenge. That is Today's question is a medium level question. Okay, I'd say it is a pretty easy one. It says that we have to delete the middle node of a linked list. So it's kind of like yesterday's question, but in yesterday's daily challenge, the particular node was given that was to be deleted. But today, we are given the whole linked list and we have to delete the middle node only. So what we can do is there are two ways. Like we can traverse up to here, up to if we see example one, we can traverse up to 4 and then delete this link and point this 4 to 1. Okay. Or what we can do is we can traverse till the middle node, till 3, and then we can copy the value 1 uh, to 7 and delete this link. So basically it satisfies both the ways. Okay, so it the final answer will be 147 and then this one, and then we have cut this link, so this one will point to 2. So here we are not deleting the reference the way I said, but we are going to delete the reference. Like it makes more sense. Okay, so let's see let's see with it let's see it with an example. Okay, so this is the example. So how can we traverse till the middle node? That's the big question. We can use two pointer. So we are going to maintain a slow and a fast pointer. So in case of odd, it's pretty clear that we have to remove only the middle element. Like here, there should be left, there should be two nodes, and right, there should be two nodes. In case of 5, okay. So we're deleting the third element. But in case of even 2 and 3 both are the middle nodes. So which one we have to delete? We have to delete the latter one. Uh, Sorry, we have to delete the last one, like the last middle node. So here we have to delete 3, and in odd, we have to delete the middle one. Okay. So first we have to point the start and the fast pointer to head and move the start pointer by a distance 1 and move the first pointer by distance 2. Okay, so here both the start and the first pointer are pointing to the head, and in the next step what I do is I move the start pointer to distance 1 and the fast pointer to distance 2, and will continue doing this until the first pointer becomes null or the first's next becomes null. Like in this case, the first's next becomes null. Try taking an even number like this one and do this slow and fast pointer. Then you will get that the fast pointer will get to null. Then wherever and we will maintain a previous pointer also. Previous is like previous is previous of start. Okay, here initially we will declare previous as null, and then we will keep on tracking the slow pointers previous node. Okay, so here like we can see that here the slow pointers previous node is initially it's null, then here it is 1, and then here it is 2. Okay, so if we are successful in keeping track of the previous node, then what we actually do is we break this link. After the whole iteration, we break this link between 2 and 3 and point the node 2 to 4 and delete from the memory or free from the memory this 3. Okay, so let's see the code. It's pretty easy one. So I have written a function. Okay, okay, so here I have written a function for finding the middle the previous element of the middle element, and then I return the previous element here, previous node here. Okay, so how did I do that? Here, as I said, I keep track of the previous of the slow node. and then I move the slow by one node and move the fast by two nodes. And until the edge cases are until and unless the fast is null, or the fast's next is double equals to null, then we break out, or we stop the iteration and we return the previous. Okay, so in this delete function, here, okay, here, if the head is null or the head's next is null, like if that there is given no a empty linked list or a single element in a linked list, then we return null because there's no middle element. Okay, so and here, uh, first we get the previous of the middle element and store it in this current variable, or the node, current node. Then we point the currents next, like I said, the current, this is 2 is the current right now, currents next to currents next to currents next, and we return the head. uh, what we can actually do is we can also free these three, so we can store this current somewhere else also. Okay, I can create another node temp and store the current, and then I can write delete temp. Okay, so what it does is it frees the space, and now we return the head. Let's run it. Okay. um, okay, it's good to go. Okay, thank you.